it's going to bond all of those grounds together because they're mounted on this metal panel. And that's connected to what's called a perimeter ground that is buried around your house or your facility, whatever it is, something outside. And we'll talk about perimeter grounds in a bit. But basically, your outside ground system that conducts lightning out into the earth. You mount all of your protectors on this same panel so that when a surge comes through, they all fire at the same time. Why is that important? If they fire at different times, then you'll get a voltage spike over here, and then at a different time, you get a voltage spike over here. That creates really substantial voltage differences. It's not for a very long time, but electricity is really, really fast. It only takes a few microseconds to a 10 kilovolt difference to develop a pretty significant arc. And that's what causes the trouble, is the voltage differences. And that's why the bonding has to be right there, and they all have to fire at the same time. So that's why you mount them all on the panel together. And this includes the non-RF and the AC power connections too. So let's talk about protected and unprotected cables. If you look at this drawing, this is just a metal panel outside somewhere. Maybe it's in your wall, maybe it's actually outside in a little garden tool thing, or your garage or something, whatever. And so this metal panel is mounted on something, and all of your arresters and protectors are mounted on this thing. And here come all the unprotected cables, your AC branch circuit that comes from your circuit breaker box, your feed lines, your rotators or control lines, your data or phone lines, all that kind of stuff. These are all unprotected, as it says right here. Once they go through the protectors, then they're protected cables, okay? And these go into your station right here. You want to keep those cables, the protected cables, away from the unprotected cables. Yeah, it looks a lot better if everything's all together and it's nicely wrapped and controlled and it's all in the same conduit or whatever you've got. Problem is, lightning will jump around your protectors, and it'll go directly from cable to cable. So you got to keep your protected and unprotected cables apart. Keep them away from each other. Now let's talk about the perimeter lightning ground system. Okay, if you go outside by your AC service panel, if you trace the big ass wire that goes outside, it'll go to one or two, probably two ground rods about 6 to 8 feet apart. Newer construction may also use what's called a UFER, UFER, or slab ground. What that consists of is a bunch of rebar and copper wire inside the concrete slab of a home with no basement, and a stub wire will come up out of that and you connect to that. And that works for AC and low frequency components of lightning. I have not been able to find any research on the high frequency characteristics of a UFER ground, but it works for lightning and AC safety. Typically, the ground that is in direct contact with the slab, and concrete is surprisingly conductive. As a matter of fact, that's how people get electrocuted, is standing in their bare feet on concrete, touching something that's energized. So you want to be careful about that. Anyway, the ground slab, it's called a UFER ground, and so that's what you connect to. If you got dirt outside as opposed to sand or what have you, you can run a big wire around your house to the maximum extent you can. You might not be able to run it through a patio or under a driveway or something. Just get some wire outside your residence, and then you connect ground rods every twice the length of the ground rod around the house. That creates a perimeter ground. Some people also connect radial wires to the perimeter wire or the ground rod, and that's fine too. That gives you a big, heavy, direct path outside for dissipation of lightning currents, and that's what a perimeter or lightning ground system is. Here's an example of a single point ground panel from my friend K4RO. Kirk lives in a split level house. His Radio Shack is directly above this big metal panel. This is kind of in a basement slash garage. And so the garage is down here and his station sits up here. Before he put in this panel, he lives west of Nashville on a pretty good hill. And every time a thunderstorm came through, he would lose some piece of equipment. Something would get fried. And finally, he bit the bullet and put in this big panel. And then here you can see his BAW that connects outside to the ground system. And when he mounted everything associated with the antenna system, that's all of his filters and switches and controllers and stack matches and all that kind of stuff. And he mounted it all on this big panel and connected it to a ground system outside. He's lost exactly 0 pieces of equipment, and that's been some years, and there have been several really big thunderstorms. So that's a real endorsement for an SPGP. Here's another example. I have a sub SPGP at the base of each one of my 360-foot towers. I live on not really a hilltop, it's kind of a ridge in Missouri. I call it the Crawford County Cumulonimbus Discharge Facility. When I bought the place, I knew there were several charred trees around, and I thought, well, you want a good radio location, you're just going to have to deal with lightning. So at the base of each tower, I have a lightning protected remote coax switch. This is an MFJ RCS4L. The L means lightning protection. It's got a gas discharge tube on each of the feed lines. MFJ is, of course, out of business, but these are still out there. You can see the hard line coming in from the station, and then you can see 3 different antennas connected to this box. This ground panel here is just a piece of aluminum flashing. That's all it is. I went to the hardware store, I got a roll of aluminum flashing, and I screwed it to a piece of plywood that mounts in a surplus plastic fiberglass electrical box. It's not expensive. And you can see the BAW connected here, and it goes to a ground connection outside the box. And here I'm going to save you some serious money. What I use for rotator control cable is irrigation system control cable, and I know there's a lot of that in Florida. This is a 10 conductor number 18 irrigation control system cable. It's covered with PCB, it's burial rated, and you don't need 10 conductors for most rotators. You need 8. So what I did was double up 2 of the number 18s, and that made the equivalent of a number 16. So this is the same as that fancy, expensive multi-conductor rotator cable, and it's really cheap compared to the special cable. So you can go out and buy this stuff by the 10 jillion feet in spools, and it's a lot cheaper than the special cable. Save the special cable for inside the station where you might want it to look good, or running it up the tower where it might need to be more flexible. Each one of these wires is connected to a gas discharge tube. That's what these little blue things are, and a sheet metal screw through the panel. That's it. Each of the gas discharge tubes cost a little more than $1, and these are the 75 volt versions, and I got them from Mauser Electronics. I just bought a box of 100, and now I've got them around. So this is a little terminal strip here, and that will serve to protect a multi-conductor rotator cable. And there's also another panel in the barn, and then I got yet another panel in a small garden shed type of enclosure before it goes into the house. My goal is just to wear out Mr. Lightning before he ever gets to the house. I just want him to go, this is too much work, too much paperwork here. So I give Mr. Lightning heavy direct pass wherever I can. Okay, so outside your house, Reason why you want to have a bonded perimeter ground system is you've got to connect all of your external earth electrodes. That means ground rods. And the NEC is unequivocal. The word is shall. And there's no wiggle room in shall. If you have new construction and you have multiple ground rods outside, the electrical inspector will require that you shall have all of those earth electrodes bonded together. Why? Okay, so if you don't have the bonding conductor, this is the bonding conductor right here, and you've got an antenna on your roof, so you ran a ground wire like the NEC told you to. Here's your home entertainment system, and cable TV put a ground rod in. They're required to. Okay, here's your telephone system. Here's your electrical panel. They all have ground rods. What if this wire is not there? What is connecting all of those ground rods together? Well, the answer is dirt. Okay, just D-I-R-T, dirt. What is the resistance of dirt? Well, it's pretty high, actually. If you went out and measured resistance between a couple of these ground rods, you might measure 10, 20, even 50 ohms or more. But what happens when you get 1,000 amps flowing through the earth and the dirt has the resistance of 10 ohms? 1,000 volts, 1,000 amps times 10 ohms is 10,000 volts. So if you do not have this wire here and you get a nearby lightning strike, even if it doesn't hit your house, and you have big lightning-sized currents flowing through the earth, you will have multiple kilovolts of voltage difference between all these different parts of your home. And that's when you hear stories like, I was sitting there minding my own business, and I saw a flash outside, and there was this big green arc between my TV and my telephone, and now nothing in the house works anymore. Okay, it's because these things were not connected together. The bonding outside ties them all together so that the resistance between all these different ground connections is as small as possible. Hopefully 0 volts, 0 ohms. It won't get to 0, but it'll be close. So that's why you want a perimeter ground system with all of the ground rods tied together. As a matter of fact, new construction even specifies that everything comes into the house at the same spot. Your AC, your telephone, your data, whatever you got. And unfortunately, we always seem to put the ham station on the other side of the house. So you have to figure out a way to get those ground connections hooked up together. But if you can swing it and put your SPGP near the AC panel and stuff like that, you can save yourself a lot of trouble. It's not always possible, but that's something to watch for. Okay, so I said earlier, don't create low impedance paths through your station. This is what happens. Okay, here's your tower. Okay, you got your feed lines. They come down here. They come off the tower and they go to this nice entry panel that you made. And by golly, it's got a ground rod right there. And then cables go into your radios, and your radios are plugged into a power supply that's plugged into a branch circuit. And here's your AC service entrance with the panel and everything. And it's got its own ground rod over here. These are not connected together. Okay, well, what you've created is a terrific path for Mr. Lightning to visit your antenna, come down the tower, flow over here. Some of it will go into the ground rod, sure. It's an alternate path. It'll divide there according to the impedance of each connection. But some of it will go, hey, I'm going to go over here and see what happens. And it goes along the feed lines. It goes through all your radio stuff, through the AC branch circuit, and whatever else is connected to the branch circuit, and then out to the ground rod that's connected to your AC service entry. And a lot of your radio stuff doesn't work anymore. Uh-oh. Well, Mr. Lightning got a path through the station to another ground electrode. So you want all of these things to be connected together, bonded together. You want everything going up and down together. So at the base of your tower, you've got a ground electrode, probably more than one, and then you got connection that goes over to ground rod near your SPGP right here. This is that big heavy line. And your SPGP has all the protectors in it, also has your AC power. So your unprotected AC power comes through a branch circuit, runs all the way over here where your AC power protector is mounted on the panel that's connected to a ground rod, and then your protected AC goes back to the radios. And then the lightning comes in. Let's say lightning comes in the power line this time. That's very common too. Comes down here. Okay, here we go. Got an AC service panel. Some of me is going to flow into this terrific, nice external perimeter ground system. I've got a heavy direct path to the earth. Most of me is going to go this way. Well, some of it might also go along this unprotected AC branch circuit. Well, aha, you've got an AC power protector right here on this panel, and it's connected to a ground rod. So a bunch of that remaining current is going to go this way. So basically just give lightning a whole bunch of ways to get to the earth outside your house as quickly as possible. Ground paths should always go around your station and not through the residence. Lightning protection at a tower. We've seen this drawing a bunch of times over the years in the handbook. You're looking right down on a lattice tower there. You've got a concrete tower base, and you should put one ground rod for each leg, and then connect these things with a heavy ground ring. As long as you got the backhoe guy out there digging a hole in your backyard, have him dig a trench that goes out about 30 feet if you can. Doesn't have to be perfectly radial, but something out into the yard, and lay out some more of that ground ring wire and some ground rods. You can use a one-shot. If you've ever used a CAD weld one-shot, you know they're a lot of fun. They're sort of like fireworks, and basically you weld the ground wire to the ground rod, and then you can bury it. You never have to look at it again. This is a great ground system for a tower. On the tower, you want your feed lines to be bonded to the tower every 50 feet. Remember that number 12 piece of wire that got the 716 volts across it because a kiloamp flowed through it. Well, when you get a lightning strike on a tower, you can easily have 100,000 volts between the top and the bottom of a 50, 60, 70 foot tower. And I don't know too many coaxial cables whose jackets are rated for 50, 60, 70,000 volts. So you get pinholes, you blow up the cable, there's all kinds of things that happen. So what you do is bond the feed line outer surface, that shield, to the tower with one of these brackets. They're available from DX Engineering, from Roan, all these different things. You put a double SO239 on there. Yeah, you have to cut the cable and put on 2 more PL259s, and then you got to waterproof them, and that's kind of a pain in the neck, but it's better than replacing the cable every so often. And so do this every 50 feet on your tower. If you've got an insulated base tower, put a spark gap around the insulator. On my insulated base towers, I just put 2 pieces of number 2. I cross them as an X, one bonded to the high side of the leg and one to the low side. And when you bond them like that, you put them just far enough apart so that they don't arc over at your full power, but they're not so close together that bugs or water will collect in there. And that's why you use the X. And you can see points on these little spark gaps where I've had a lightning discharge a little tiny pit or a little black spot. So, and lightning jumps around your insulator, and until that arc quenches, it'll hold the voltage down to less than 100 volts. All right, on to RF management. Got to remember that everything in your station is an antenna. Absolutely everything. And the best, the antenna, excuse me, the more you don't want it to work as an antenna, the better it will be, okay? That's just the way it works. So everything in your station is an antenna. And where is this antenna? It's outside, right? Okay, so you're probably electrically very close to your antenna. For example, you got a 40-meter dipole in the backyard. What's a wavelength of 40 meters? It's 40 meters. That's about 120 something feet, 130 feet. Okay, if you're closer than 130 feet to that antenna, you're in the near field of the antenna. So everything in your station is going to pick up some RF energy. Your grounds, your cables, your mic cable, your PC stuff, all of it. It's going to pick up RF and it's going to be flowing around in ways that are very hard to predict. So first of all, we're going to forget about this mythologically all-band RF ground magic 0-volt connection. Doesn't happen. What you do is concentrate instead on bonding. On bond everything in your station together. So it's all going to go up and down together. And no matter how hard that RF works, since everything is electrically short, there's going to be minimal amount of voltage between point A and point B, causing that keeps everything electrically low impedance. You get an amplifier, not only neighbors, and you set your equipment on it and then connect to it, or you can connect a bus in the back, and we've all seen pictures like that for many years. This is usually a piece of half-inch copper pipe, and you use clamps that are made for ground rods. It's the same diameter as the pipe, and you connect your ground wires from all of your equipment, including computers and even unpowered stuff. If it's metal, you need to have this grounding connection to it. A wire to equipment enclosure, that number 14, number 12, that's the way to do it. And then you have a strap or a heavy braid that runs over, it runs over to your single point ground panel. And that's a bonding bus. Okay, now we talked about ground loops and how hard it is to get rid of them, and you really can't. Okay, what you can do to help things work in your favor is you want to minimize the loop area. The amount of voltage that is induced in a loop is directly proportional to the area. The smaller the area, the smaller the voltage, the smaller the current that flows around it. So you want to use short cables, or you can coil them up. And if you coil them up in a figure 8, that tends to pick up less of the RF because the two turns tend to cancel each other out. They're in opposite directions. So use that bonding bus. Here's a bonding bus right here. And here's your ground wires to the bonding bus. Keep your cables together. You can tie them together with Velcro straps or even twist ties from like a bread bag or something. Minimizes the area of the loop. Always use shielded cables for everything except perhaps power. Just because one little control switch that just got a couple of twisted pairs, a couple of wires in a twisted pair, and they're not shielded, hey, that's a great antenna. That will pick up RF into whatever piece of equipment you've got connected to it. So always use a shielded cable and make sure the shield is connected to the grounded or bonded enclosures or wires. You want to use short straps or wires for all this stuff. And we're getting close to the end. Okay, so here's an example of an RF management reference plane. Remember that piece of flashing that I showed you that was in the box? This is in my station. This is your basic Costco plastic table, and I just took the sheet metal here and I stretched it out on top of the table, and I put some sheet metal screws through that. Problem solved. So I have this big low impedance strap that runs under all the equipment, and all of my cables run right on that. Now at the time, I was using a half-inch piece of copper pipe as a convenient way to connect the ground wires from keyers and switches and radios and stuff, as opposed to connecting them directly to the reference plane. But what I found was these cool things. These are ground bars that you can buy at the store for AC service panels, and they're relatively inexpensive. Remember that anything you can buy that is made in quantity for consumer level use is going to be way cheaper than buying something that's special for electronics. So what I do is I go to the electrical section of the hardware store and I buy these things. You can buy them in 5s and 7s and 9s and weird numbers all the way up into the 20s. And basically you just screw them down to this. So you can see right here, I'm making a new station table here. This is the aluminum flashing, and I'm screwing it down to the tabletop. I just set this ground bar right on it, and I screw it right to it. And under each one of these, you can't quite see it here, is a tooth lock washer. Either internal or external will do. And that makes sure it bites into the metal and keeps you having a secure connection there. And then I use a BAW to go over to my station ground system. And I've got a big terminal. This is number 6. So one of these 1/4-inch terminals here, sheet metal screw, a stainless steel washer, and an external tooth lock washer. And I've got a couple of these things. One is here, one's over here, and then I put one little one in the middle. And then I use this whole thing as my bonding bus. Don't have to use a copper pipe. I use these things, and they're made to screw down and hold on to wires. So I found them to be actually uh, a better solution. Okay, so let's review the ground system. One single solid ground system. It's like one ring to rule them all. One single solid ground system with short, heavy, direct connections satisfies all of the requirements for AC safety, lightning protection, RF management, and clean audio as well. It really helps, particularly if you're running FT8 and you've got a low-level audio connection from your computer to your mic jack of your radio. That's pretty small audio, so it doesn't take much RF current to mess with that. So you want a good single solid ground system. You want to bond all of your grounds together. That includes the AC ground, your lightning protection conductors, and your RF management, whether you use a bonding bus or a reference plane or whatever. And you want to keep all of your protectors together as close as possible. Why? So they fire at the same time. And when they fire at the same time, all of your stuff goes up and down together. And the perimeter ground outside helps keep lightning currents outside the building. Give the lightnings what it wants, which is heavy, direct path to the earth. That's where the charge wants to go. Okay, and here's some additional resources. As I said, these are in the PDF slides that I sent to the club. And start off with the National Fire Protection Association. It was formed to write the National Electrical Code back in the early days of electrification, when people were making all kinds of weird decisions about how to hook up electricity, and things were getting burnt down and people were getting electrocuted. Finally, the fire protection people got together and said, this won't do. How can we do this right? How can we tell people to do this right? That's where this comes from. International Association of Electrical Inspectors, that website has good stuff. Mike Holt Enterprises, Mike trains electricians and electrical inspectors. There's tons and tons and tons of tutorials and white papers and drawings and all kinds of good stuff. And then Polyphaser has been around ham radio and communication systems for a very long time. And they have a bunch of white papers and tutorials on lightning protection, including some specifically for amateur stations, our radio amateur stations. So look them up. Here's the standards on which a lot of the grounding and bonding book was founded, and where a lot of this material comes from. Standards and guidelines for communication site better known as Motorola R56, is available online as a PDF. The FAA has a document 6950.19a, and it covers a lot of really good practices. If you're really interested in doing it, and finding out what the FAA requires at their stations, that's your standard. IEEE standard 1100, that's expensive and kind of hard to get. You can get it through your library, but that's power and ground systems. That's where a lot of the IEEE stuff on power, AC power is. And then Mill Handbook 419A, grounding, bonding, and shielded for electronic equipments and facilities, volumes 1 and 2. And you paid for it, guys. It's free, it's available online, and they will show you what they do at their transmitting facilities for HF and how they construct a perimeter ground and how they bond to the tower and all this kind of stuff. It's all available, no cost. There are books and online material. Ron Block, The Grounds for Lightning and EMP Protection. Don't forget his new book, Lightning Protection, and the RAND book, Lightning Protection and Grounding Solutions, written for the Polyphaser Corporation back in 2000. All that is excellent stuff. One of the best kept secrets in amateur radio is the ARRL Technical Information Service. Go to the technology tab on the webpage, you'll find it. You want to look at the electrical safety page. You want the grounding page and the lightning protection page. A lot of good material in there. And boy, there's a lot more stuff in the ARRL Technical Information Service. And so that's worth poking around. Once you get in there, it'll be hours before you get out. So I'd like to say thanks, and I'm going to hang around, and you guys can ask some questions, and we'll go from there. So I'm going to turn it back to Mike, and we'll just ask some questions. So have at it.
I'm sorry.
I think I baffled the crowd.
We appreciate you taking the time tonight to be with us and go over everything. We did have a little bit of a technical internet snafu during part of your presentation, but we do have most of it recorded that we usually offer back to our members to be able to go back and watch through it, and then also anybody that wasn't able to be here.
Okay, I wondered what was going on. I got
the battery on the power on the internet device went out, and it wasn't charging faster; it was depleting faster.
The internet battery discharge. Oh no, yeah. The internet had a dead battery.
We usually go at this point and do the questions and answers and stuff, but we're running a little bit short of time at the center that we're in. It's ready to close. What I'd like to do, if possible, when we send out your PDF file of your presentation to the club, is it also okay to share your email address, or would you like for us to field the questions they have and then send them to you directly?
You betcha. Okay, well, guys, thanks.
Is it okay to share your email?
Enjoy the rest of your show.
Is it okay to share your email then?
Yeah.
Okay. All right. We'll do that. And then if anybody has any questions, they can contact you directly. It'd be easier. We appreciate it again, taking the time to be with us tonight. Thank you.
Okay, no problem. I'm available via qrz.com.
Thanks. All right, guys, we went ahead and pulled out 3 tickets real quick for our drawings in advance, so that way we can wrap things up a little quicker. Do want to remind everybody that our next meeting is May the 7th here at Beardall Senior Center at 7:30. Our presentation will be again on Field Day, and we'll talk more about Field Day at that at the next meeting. Also, I just remind everybody that the board is not changing. The results did come in. Big, huge thanks to Kevin Jackson for challenging the directors. Don't give up, Kevin. There's always another opportunity to be able to be on the board and stuff. So we appreciate it. Drawing 3 tickets in advance, your choice of what you get. You got 2 of the grounding and bonding books. Very important to have in Florida, and also in case you need an antenna. Your choice if you win. 7959, last 4 digits, 7959. 7959. Bob? Books, okay. Next one is 7979. 7979. The short person. Book or antenna? Book. All right. Next one is 7968. 7968. 7968. That's yours. There you go. Thank you. Appreciate it very much. Thank you guys again. Appreciate it. We'll see you again next month.